All right, good morning, everybody. Welcome back. We are taking a look at our day 4 topic, which is on power of a power property. Our essential question today says, how do I use the power of a power property? And we're going to use it to simplify expressions with exponents. So what is it? Power of a power. So when raising one power to another power, we multiply the exponents. So notice in our algebraic expression here that a to the m is being raised to the nth power. Okay, so something that's already a power, a to the nth power, is being raised to another power on the outside of the parentheses. And the trick there is all we have to do is take those two exponents, m and n, and multiply them together. We can see in the example below with the numbers, all we're doing is multiplying 3 times 4, and we get 12 as the new exponent. So a cubed raised to the 4th power, 3 times 4 is 12, becomes a to the 12th power. Now, why does that work? So if we were to look at this as expanded form, right, when in doubt, write it out, we can write this as a to the 3rd power multiplied by itself 4 times. That's what that 4 on the outside represents. So we're trying to figure out what is a cubed times a cubed times a cubed times a cubed. And in this case, we can use our property from earlier this week, where if we're multiplying powers with the same base, we just add those exponents up. So a to the 3 plus 3 plus 3 plus 3. And we realize, well, that's silly to add repeatedly. That's the same thing as a multiplication problem. There's 4 3's that you're adding together, so 3 times 4 is 12, a to the 12th power. You could extend that even further if we wanted to, and we could rewrite each group of a cubed as a times a times a. And when we do that, we see that we have a total of 12 a's being multiplied together, so that will also show a to the 12th power. So our property shows that the shortcut is really just multiplying the exponents together. Again, power of another power. You multiply the exponents together. Let's see how that works with a few examples. So example number 1, we have x to the 4th power raised to the 2nd power. Again, the 4 and the 2 are both exponents right next to each other. And that means that we want to take those two exponents and multiply them. Since 4 times 2 is 8, we would get x to the 8th power. In number 2, we have b cubed to the 7th power. So we just need to multiply the exponents 3 and 7, and we get b to the 21st power. In number 3, okay, it gets a little more advanced this time. We're going to have to start bringing in some of the other properties with the power of a power property. So in number 3, what we have is product 2 times y to the negative 6th power is all squared. Now, before we just multiply those exponents together, we have to realize that what's being raised to the 2nd power is another product. So we have to think of it as 2 times y to the negative 6th power, and each part of that needs to be squared. So the 2 is going to be squared, and the y's are going to be squared. This is that property from the other day. It's our distributive property, essentially. So when we go to evaluate each part or simplify each part, the 2 squared ends up just being 4. Okay, 2 squared is 4. But then when we take care of the y's, y to the negative 6th power squared, remember that's our power of a power now. We want to multiply together the two exponents. Negative 6 times 2 is negative 12. So we get 4 times y to the negative 12th power. All right, so we've done some of the properties, but we're not done yet because we have a negative exponent. So now we have to flip the positive with that negative exponent. We're going to go ahead and move that part to the denominator, as we have been here for a few days now. Move that down to the denominator, and our final answer is going to become a 4 in the numerator And when we move the y's to the denominator, we make the exponents positive. 4 over y to the 12th power. Now in number 4, we kind of start out the same way, where we have a product inside the parentheses that's being raised to the same power. So we have m squared times n cubed, and both of those products, or both of those factors, excuse me, inside that parentheses are being raised to the 4th power. So what I have to do now is show that each one of these is going to be raised to the 4th power. And then I don't want to forget about that n squared that's at the end. Okay, it still kind of has to come along with. So all I did was I distributed the 4 to both factors, but I realized that each factor already has an exponent. So now we need to apply power of a power within that. So m to the 2nd power raised to the 4th power again. We multiply the exponents, and we're going to get m to the 8th power. 2 times 4 is 8. And then we simplify the next part. N to the 3rd power raised to the 4th power. We multiply those exponents, and we will get n to the 12th power. And then we don't want to forget about that n squared at the end. That's still part of the problem. All right, so we took care of the power of a powers. So what's next? Let's see. Everything has a positive exponent. That's good. Oh, look at this. We have one of the bases is showing up more than one time. So we have to combine the n's together. So if you think about how do we combine n's? N to the 12th power times n to the 2nd power. Well, we're just trying to figure out how many total n's are there. So the m's are going to stay the same. But for the n's, you guys remember what we do with those exponents? We don't multiply them. We only multiply when it's power of a power. In this case, we add the exponents. 12 plus 2 becomes n to the 14th power. Because we're just trying to figure out how many total n's there are in that multiplication string. And if you rolled it out n times n times n times n over and over, there would be a total of 14 n's in this problem. So we have final answer, m to the 8th power times n to the 14th power.